This is an ancient alien object that is rapidly approaching our sun. For the past month, all of Earth's most powerful telescopes have been pointed at this one strange light in the sky. They have been looking for answers, but what they saw has only raised more questions. Now time is running out. Soon the object will disappear from our view, hidden behind the bright light of our sun, leaving us with the mystery to solve. What is this thing? Officially, it's known as 3I Atlis, meaning third interstellar object, meaning it comes from one of those little stars you see in the night sky. We're not sure which one exactly, but we are pretty sure that 3I Atlis comes from a very old place in our Milky Way galaxy, from a distant solar system that could be twice the age of our own sun. This is only the third time we've been able to spot one of these interstellar visitors. The first was called Oumuamua, a crazy cigar-shaped rock that came tumbling into our solar system in 2017. We still don't really know what this thing was, but we know it was weird. It's already looking like 3I Atlis could be even weirder. Then there was 2I Borisov, which has become the underappreciated middle child of the bunch. That's because it was decidedly less weird. Borisov looked like a comet, acted like a comet, and that's almost certainly what it was. A comet that came here from another star, which is still pretty cool. But 3I Atlis has quickly become our best opportunity yet to study a genuinely strange alien object. This is one of those situations where the more we learn, the weirder it gets. Officially, the object was spotted for the first time on July 1st, 2025 by the Asteroid Terrestrial Impact Last Alert System, or ATLAS, hence the name. At that time, it was between the orbits of Jupiter and Mars, but still much closer to Jupiter. Since then, we've learned that 3I Atlis was actually seen for the first time on May 7, 2025, by the Transiting Exoplanet Survey Satellite, also known as TESS, which was busy looking for distant alien planets, so it didn't notice our new visitor at the time. When that first image of 3I Atlis was taken, the object was still traveling between Saturn and Jupiter. That also helps give us an idea of just how fast this object is moving. When NASA launched the Voyager probes on a direct course for Jupiter, it took between 18 and 23 months to reach the planet's orbit. We know that 3I Atlis was near Jupiter in May, it's now passing by Mars in September, and will reach the Sun for its closest approach on October 29th. Then it will be back out at the orbit of Jupiter again by next spring. That's how we know for sure this is an interstellar object. It's traveling way too fast to be caught by the gravity of the Sun, which is known as a hyperbolic trajectory. What's interesting about the observation made by TESS is that even when 3I Atlis was out beyond the orbit of Jupiter, it was already looking very bright, and then got much brighter over the 3-week period that TESS was able to see it. That is a little weird compared to the comets we are used to seeing. Typically, those comets are big chunks of frozen water mixed with various rocks, dust, gas, and stuff at the edge of the solar system. As that chunk of ice starts to get closer to the sun, it warms up and begins to melt. In the vacuum of space, this process is technically known as sublimation because liquid cannot exist in a vacuum. The ice transitions directly into gas, and that's what makes the big, bright, fuzzy halo around the comet, technically known as the coma. This is important because our typical water-ice comets will not get warm enough to sublimate and develop their coma until they pass through the orbit of Jupiter and start approaching the asteroid belt. But when TESS first saw 3I Atlis on May 7th, the object was still way out on the other side of Jupiter, yet it was already super bright and getting brighter every day, indicating that sublimation had already begun. Based on this observation, we know that if 3I Atlis is a comet, it's much different from any comet we've seen before. It's even wildly different from Oumuamua, which was infamous for showing no visible signs of sublimation at all, no coma. They're like opposites. It's also different from 2I Borisov, because Borisov did all the usual things we would expect a comet to do, so it was strange in how familiar it behaved for something so unusual. As we continued to observe the approach of 3I Atlis over July and August, it kept getting weirder. The coma around the object began to form a tail, which is normal for a comet, but the one around 3I Atlis started growing in the wrong direction, pointed toward the sun. We know the sun is the primary source of light, heat, and energy in our solar system, but we also have to think of the sun like a big fan, constantly blowing out solar wind. This typically shapes the tail of a comet as the solar wind blows back the rapidly expanding cloud of gas and dust around the chunk of ice to create a long trail. It's like when a dog sticks its head out of the window of a car and the air pushes its face back. Adorable. Now imagine if the dog stuck its head out and its face stretched forward. That wouldn't make any sense, right? That's why people were baffled when it started to look like the tail of 3i Atlis was forming in the direction of the sun, against the solar wind. These are just some of the many questions astronomers were trying to answer when they decided to point the world's most powerful space telescopes directly at 3i Atlis, including Hubble, James Webb, Spherex, a cone-shaped satellite that studies the origins of the universe, and TESS, which was brought back in to take a second look. It was NASA's most advanced observatory that provided the best insight so far into what 3i Atlis actually is. Again, we have some answers, but also new questions. The biggest finding was that the coma surrounding 3i Atlis is made almost entirely of carbon dioxide, meaning this object is not a big chunk of water ice like the comets we are used to seeing. Although it does contain some water, the ratio of CO2 to H2O is measured at 8:1, which means there is 16 times more CO2 in this object than what you would expect in an average comet. The cloud of CO2 around the object is now thought to be gigantic, with a radius of up to 300,000 kilometers, almost half the size of the sun. It's way bigger than what we anticipated based on those first observations in July. This has observers thinking that the solid object at the center of the cloud might be a lot bigger than expected as well. At first, we thought the core of 3i Atlis might be up to 20 kilometers wide. Then that was tempered down to maybe 11 kilometers. But now, based on these new observations, it's thought the actual size could be as big as 46 kilometers across. That's big, but not huge. We have found comets in our own solar system with cores over 100 kilometers wide. But the massive amount of CO2 compared to the small amount of water is something we've never seen before. It's basically the opposite of what we would expect in the halo of the comet. So it tells us this object was created in a star system with very different raw materials from our own. The ratios are all wrong, which makes 3i Atlis so genuinely alien in nature. But was it made by aliens? There was another bizarre discovery this summer during an observation of 3i Atlis by the Very Large Telescope in Chile. The VLT was able to detect the presence of nickel metal in the coma of 3i Atlis, but was not able to detect any trace of iron metal. Confused? Good. Iron and nickel are natural partners, the most abundant heavy metals in the known universe, forged in the hearts of dying stars and blasted out into space by supernova explosions. Because of this, iron and nickel are always found together in cosmic places like asteroids, moons, and planet cores. The only time we see nickel on its own is when humans purposely separate the two metals in an industrial process. So, how did nickel find its way into a comet without bringing along any iron? Good question. We don't know. It's pretty weird. This brings us to everyone's favorite explanation: aliens. There is no shortage of theories about what kind of artificial spacecraft we might be looking at. In fairness to those theorists, they're not just making stuff up. They take the known data and create a slightly more speculative interpretation. For example, we know 3i Atlis got brighter as it passed by Jupiter. Yes, it was getting closer to the sun, but that doesn't account for the amount of brightness added. This could be explained by early sublimation due to the object's unusually high CO2 content, or it could be an alien space probe that started switching its lights on. There's also a theory that the object is surrounded by a cloud of CO2 because it's a giant spaceship full of living organisms breathing out CO2 like we do and venting the waste into space. I've even heard it said that 3i Atlis might be a giant living organism itself, consuming dust and gas as it moves through the solar system and releasing CO2 as an organic byproduct. The cool thing is that, as of right now, no one can say with 100% certainty that this is not true. It's probably not, but the same goes for the nickel metal. No one can say for sure what's going on with that finding. So you can't definitively say it's not an artificially constructed alien spacecraft. Again, it's probably not. This is why scientists and astronomers are quickly trying to learn as much about 3i Atlis as they can in the small window of time available. We have an opportunity to get a photograph of this object as it passes close by Mars in early October, coming within about 28 million kilometers. Still pretty far, but close enough for 2 European Mars orbiters to get a decent look. The European Space Agency will use both the Mars Express and ExoMars Trace Gas Orbiter to observe 3i Atlis using high-resolution cameras and color imaging systems. We won't get a beautiful close-up, but there should be just enough resolution to distinguish between the cloud of gas surrounding the object and whatever is at the center of that cloud, so we could maybe get an idea about the shape of the object.
By late October, from our point of view on Earth, 3i Atlis will pass behind the Sun, and we won't be able to see it again until December, at which point it'll be on its way out of the solar system. We'll get one last chance on March 16th, 2026, when 3i Atlis flies past Jupiter at a distance of 53 million kilometers. Still pretty far, but we do have one active probe out there in the orbit of Jupiter called Juno. It's an older spacecraft at the Jupiter system since 2016, and the end of its scientific mission is scheduled for September 2025. NASA was planning to crash the probe into Jupiter to dispose of it and see what happens along the way, but another potential end-of-life mission could be to try to intercept 3i Atlis on its way out of the solar system. As weird as it's been studying this object so far, we are not done with it yet. There is still a lot to learn. We will get answers, but we'll probably also get just as many new questions. That is what makes this all so fun.